Good afternoon, and thank you for standing by. Your lines are in a listen-only mode until the question and answer session of today's conference. At that time, you may press star followed by the number 1 to ask a question. Please unmute your phones and state your first and last name when prompted. Today's conference is being recorded. If you have any objections, you may disconnect at this time. It is now my pleasure to turn the call over to Catherine Hamilton. Thank you. You may go ahead and begin.
Thank you, and good afternoon. I'm Catherine Hamilton with NASA's Office of Communications. Following Hurricane Nicole, which made landfall in Florida earlier this week, teams at NASA's Kennedy Space Center in Florida have been working to complete inspections and assessments of the Space Launch System rocket, Orion spacecraft, and associated ground systems ahead of the next launch attempt for the Artemis I mission. Jim Free, Associate Administrator for the Exploration Systems Development Mission Directorate at NASA headquarters, is here to talk with us about the status of inspections and preparations ahead of our next launch attempt. Jim will share a few opening remarks, and then we will take your questions. Reporters on the line can enter star 1 on your phone to be entered into the question queue at any time. Jim, I'll turn it to you.
Yeah, thanks, Catherine, and good afternoon, everybody. Thanks for taking the time to be here, and I'm sure have questions, but to hear where things are at. First, I'd like to acknowledge what today is. That's Veterans Day, and my thanks to all the veterans that have served us so well, and certainly those that are on our Artemis team. It's a great honor to work with them, and appreciative of their service. So let me start first right out of the gate saying right now there's nothing preventing us from getting to the 16th. We do have some work to do, and I'll highlight a little bit of that for you as I go through my opening remarks. I do want to thank our workforce down at Kennedy and really across the agency, but certainly the folks at Kennedy that, again, worked through a storm and got back on site, and thanks to Janet Petro down at Kennedy for the group that keeps everything going there, the ride-out team. We're thankful that they're okay through all this, and everybody got back on site starting to work yesterday. So, but let me back up from where we got to yesterday. I know there's questions about our decision to roll out, our decision to stay. We did have two very focused and deliberate meetings on both before we rolled out. We did take a look at what the predictions were for the storm at the time, of course, with our Space Force colleagues informed by the National Hurricane Center. And at the time, we did say, hey, this could be a risk, but what the forecast then that was going to be pretty loosely formed, and the wind speeds were going to be much lower. And we got out to the pad and started doing the hookups, and then it was, hey, this storm looks stronger, and here's the predictions. I think we had that meeting late Sunday evening, and had the discussion about the risk of rolling back versus the risk of staying at the pad, and when we could disconnect and start the rollback. When that time frame looked like we'd be able to get there, the winds were really high, and the risk of rolling, that dynamic movement, which in general drives a lot of load into the vehicle, and the risk of moving with the high winds, we decided to stay at the pad. We had predictions then that the storm, the winds were going to be high, but still within our certification limits. So I can assure you that I think it was a 2.5-hour meeting, 3-hour meeting, where the experts from the Space Launch System team under John Honeycutt, John Blevins and his team talked a lot about the risk of both and the analysis that went into both, so we decided to stay. And I'm happy to answer more questions about that process. But we did have, of course, a team on the center above and beyond just the ride-out team that, looks out for watching for power on the vehicle, keeps an eye on the vehicle. We did a visual survey of the vehicle before, high-resolution photography, so that we had a baseline. And actually, we had done several of those before, so we had a baseline before the storm. And then obviously rode through the storm and looking at issues now on the backside. And I'll share a few of those things that we've been looking at. There's some loose RTV on the Orion that they're probably going to snip off. They can reach it to snip it off in the from the crew access arm, it looks like, and probably disposition to not replace it. Maybe too difficult from where we're at, and of course we'll look at the risk of not replacing it. There was a tear in one of the engine rain covers that we're going to be able to fix. Some water in the crew access arm that we're able to take care of. So those three things I think are behind us. We did have one of the umbilicals to Orion that came off its tray. They sit in a tray to stay aligned, and I'm hopeful that we can get the picture out there of the folks going out on the Orion umbilical arm to move that tray back. One of those folks we learned today and is a veteran, so even more special day for him. See these couple folks out on this arm, folks above on the crew access arm, helping guide them. So you figure the vehicle is 322 feet tall. They're basically at the base of the Orion capsule. You can imagine the height they're at, even just to the ground level, let alone below the pad surface. So that issue was straightened out, and the umbilical's back in the tray. We do have an issue on the ground side of one of the electrical umbilicals on the hydrogen tail service mast unit that was exhibiting some erratic signals. The team is out at the pad, taking that apart, doing some visual inspection, figuring out what the issue is there and what we might need to do in terms of replacing that harness. We do have a backup harness that looks like we'd be able to use if it needs to be replaced. And then the non-controversial wind discussion, which I know there's been a lot of thought about outside, and I can tell you that the thought inside the agency has been even greater. I'm going to figure out the best way to step through this. So we did put a portable anemometer on the at the 55-foot level on the mobile launch tower, and measured the winds at the 132-foot level as well. In addition, there were a number of streamers put out on the vehicle to look at wind direction during the storm, as monitored from the cameras. The 60-foot reference is where data has been taken over a number of years, going back to the shuttle program. So that's why it's you hear it's reference to that. So basically, it's measured this one time at the 55-foot level, all the time at the 132-foot level, and then there's also measurements at the top of the lightning towers around there, which is at the 457-foot level. And then everything in between is extrapolated those different heights. And then the certification limits are determined for each of those heights. During the event, the hurricane, all the measurements taken showed no breaking of those limits. So the wind speed, so the load's going to vary at each of those heights, and the peak we can take at each of those heights. None of those were exceeded for our certification limits. In addition to that, we take what's called the flight readiness analysis cycle. We never saw anything above those limits. That's 75% of what we can take, which means we have another 25% of margin on top of that before we even get into our 1.4 factor of safety. So that's the wind limits. We also measured the load at the vehicle support posts and at the vehicle stabilizer. So at the bottom of the vehicle, and then about 2/3 of the way up the vehicle as well. Those design limits are captured in our Space Launch System requirements documents. None of those were exceeded. So from our perspective, we stayed within our certification at the winds that we saw during the hurricane. I think it's safe to say for all of us, we obviously would not have wanted to stay out there. The best place for the vehicle and those kind of things is the VAB. We could not make it back to the VAB and be safe. So we stayed where we were, and our predictions and our certification limits protected us from the storm. So and that's a complex set of calculations that our team does. Using, I think the comment made was that, that's the beauty of eigenvectors, which for an engineer to hear, that's a heartwarming thing. They do a great job at giving us a hand in understanding how we transform through the structural matrices that go into these calculations. So our near-term plans, we're going to start to power up the vehicle today. Power-up's not affected by that electrical connector that I mentioned earlier. Move into our program-specific engineering test, or PSETs, start on Sunday. We have our L-2 still on track for Sunday at 1600, and then from there we'll press to the launch count. So right now as I said at the top, there's nothing preventing us from getting to the 16th. So with that, Catherine, I'm happy to take any questions.
Thank you, Jim. We'll now take questions from reporters on the line. So those on the phone, again, can press *1 to be entered into the queue at any time, and you can press *2 if you'd like to be removed from the queue. Your lines are all on mute now, and the operator will open and close your mic when we come to your question. And please do keep it to one question so we can get to as many of your fellow reporters on the line as possible. So we'll start with Marcia Dunn of Associated Press.
Yes, hi, thank you. I'm just wondering what the chances, the risk of internal invisible damage might be to the rocket, and for all the plumbing with the hydrogen fuel lines, the seals, are you anticipating more potential leakage because of the shaking vibrations from the storm that the rocket had to withstand? Thanks.
Thanks, Marcia. I mean, the measurements that I talked about, those certification limits that we pick for the wind, and measuring at the vertical vehicle stabilizer, and then the VSP as well. That's we kind of calculate and propagate those loads into the vehicle, so we get a way to look at how those loads propagate down to specific areas, and then factor those loads in when we design it. So those factors of safety, those design margins, give us confidence that we should be okay. As far as leakage, there's purge on the vehicle all the time, so we're purging to make sure that we keep any outside atmosphere or moisture out of the vehicle, and that's intended to protect those seals as well. So from our perspective, those purges stayed up, and we feel good about the interfaces and then the design of the vehicle based on the environments we saw.
Thank you. Our next question is from Lauren Gresh of Bloomberg.
Hi, thank you so much. I'm just wondering if you can clarify a bit, what are the biggest structural concerns associated with winds that exceed what the rocket is designed to handle? And also, I just want to talk about those numbers that we talked about before the hurricane hit, because we had discussed the SLS being able to handle wind gusts of up to 74 knots, but NASA did confirm wind gusts of up to 100 miles per hour. So are you saying that the rocket can officially handle wind gusts of up to 100 miles per hour? Thanks.
Yeah, so thanks, Lauren. So the 74 knots is at a height. The 74 knots is at 60 feet. We extrapolate up. If you think about the wind speed, the wind when it's unimpeded gets faster as you go higher. So we extrapolate up, and in height, and that wind speed goes up. So when you get to higher values, we would expect to see higher wind speeds, and we designed for that based on that extrapolation. So, we agree that there were higher values seen, and those values are within our capabilities because we design for those as you change height. To your first question, there's strength and fatigue that go into things, into our design. Both of the parameters for strength in terms of the wind gusts and the fatigue of what we saw at the vehicle support post and the stabilizer all tell us that we were within the limits in both strength and fatigue.
Thank you. Our next question is from Irene Kloss of Aviation Week.
Thanks, Catherine. Good afternoon, Jim. Hindsight being what it is, was there overconfidence in that 40-knot wind prediction that you had before you did the initial rollout? And if this storm had been worse or closer, what would have been the risks to the rocket? Do you feel you got lucky?
Yeah, thanks, Irene. Thanks for your questions during the week, too. Yeah, I wouldn't say overconfidence. I've tried to share before. I think there's this impression that there's this nature of us taking for granted what some of these storms are, and that's certainly not the case. I mean, we had our partners in the Space Force, Melody and Mark, given us their predictions. I think the predictions we had at the time was it was going to be loosely formed. I mean, I think you all have seen the news reports this week about the rarity of a hurricane at this time. So I don't think it was overconfidence. We talked a lot about. I think even at the final decision poll, there was discussion about, hey, let's make sure we're understanding and talking through all the issues. I can tell you that the team absolutely did that. I never heard a bit of overconfidence. I think there were folks that challenged it in both directions. So I think the group that cares the most about this rocket is the group that's on those decision fora making those decisions. So I would never expect, or have I ever heard any overconfidence or cavalier nature.
Thanks. Our next question is from Chris Davenport of the Washington Post.
Hey, Jim. Thanks for doing this. Just want to check, it's fair to say that, I guess it's one of these hindsight questions, that if you had to do it all over again, you wouldn't have rolled it out to the pad knowing what you know now. And just want to confirm that the RTV, that's essentially that caulking that was sticking out. Thanks.
Yeah, that's correct, Chris. On the RTV, it's a sealant between some of the gaps on the launch abort system on Orion. And on the hindsight thing, I think if we knew on the night before we were rolling out that it was going to be a hurricane, we probably would have stayed in the VAB. I think that's safe to say. I represent the team. I don't speak for them, but I think in that case I can probably speak for them.
Thanks. Our next question is from Gina Sunseri of ABC News.
Jim, do you think you learned anything surprising about the robustness of the system because of the hurricane?
That's a good question. I think what we learned was, I don't know if it's anything surprising because I kind of shared with you that, it was within our design certification limits. I think we learned that the measurements that we have at the pad are good to give us the data we need to evaluate the health of the vehicle after, environmental exposure like that. I think it validates what our design requirements were. I think when you start design requirements, 10 years before you get to some of the stuff sitting on the pad, you start to think, am I being too conservative? I can assure you that I've challenged myself and teams of, are we being too conservative? And in the end, in this case, we proved to have the right amount of conservatism in it. And as I mentioned, we didn't even touch the 25% margin or the factor of safety. I'm sure there's things we're going to learn about this for future vehicles. Probably maybe look at roll decisions a little bit in the same way that we did, because I think we learned a lot about how we make decisions that far out. We certainly have learned a lot about processing at the pad. So the Sunday night call, we had Charlie Blackwell Thompson thinking of every option possible of staying connected as long as we could. What can we disconnect? We learned a little bit of that from Hurricane Ian too. So all of this is learning, I think, for future processing. But as far as the vehicle itself, I think we validated the requirements that were set a number of years ago.
Thank you. Our next question is from Eric Berger of Ars Technica.
Hey, good afternoon, Jim. Thanks very much for doing this. I wanted to follow up on Marcia's question about concerns on the structural integrity of the vehicle. And I'm just thinking about things like the strain on fasteners and other materials inside. Are you going to be able to do any kind of analysis? I know the shuttle had access points where they could sample the internal structure of the vehicle, and I'm just wondering, are there those kind of ports on the SOS, or are you just going to assume that since you didn't hit the wind limits that everything is probably good inside, since, as I say, it was designed to handle those kinds of loads? Thanks very much.
Thanks, Eric, and thanks for your continued interest as well. Let me ask Catherine to follow up with you on specific strain measurements or accelerometers that the team might have access to. I don't want to give you the answer that came to the top of my head, because I want to make sure we get you the complete answer. As far as are we just going to rely on this? As I said in my opening, and I think to Marcia's question as well. You take your hold down points, in this case the support post and the vehicle stabilizer, and you kind of propagate those loads into everything inside your system. So, a set of fasteners buried deep in the vehicle, those loads are born out of where the loads are generated from. So they're generated where the stabilizer is and at the support post, and propagated up to that small set of fasteners. So if we stay within the design limits at those local areas that I talked about, by the time they propagate up, and in the models that we use in the finite element models, we should be clear, because that's how the system works. And one thing I should have mentioned at the beginning too is the modal test that we did on this vehicle out at the pad also helped us validate the models that set these loads. So we would expect that propagation that we saw in the modal test that was established in the analysis that set the requirements for all the fasteners buried deep inside the vehicle to correlate. But let me follow up with the team and see if there's any, like I say, accelerometers or strain gauges that they might get a reading on that would give them further data.
Thank you. Our next question is from Bill Farwood of CBS News.
Yeah, hey, thanks. Jim, just following up that just a little bit, given the readings at the hold-down post and at the stabilizer, is there any sense of how much this rocket actually moved in the wind? I mean, everybody's remembers the shuttle and the twang, when the engines would start and the nose would, lean way off vertical and come back. Obviously, nothing like that's going on in a storm like this, but did it move at all? And final question is, did you get nervous during all this personally? watching that storm roll through. I'm just wondering how you reacted to it as it actually played out. Thanks.
On your first question, Bill, on the movement, again, let me follow up. This is the danger when you let a propulsion guy talk about structural issues. I know enough to cause to give you the story, and but I don't know on movement. I will find that out, and we'll follow up through Catherine. Did I get nervous? I don't know if nervous is the right word. I mean, we have our rocket out at the launch pad and in bad weather, and honestly, I've been down at KSC and watched a crazy thunderstorm go right over the pad and think, man, that's tough to watch. But we also design it to be out there. If we didn't design it to be out there in harsh weather, we picked the wrong launch spot, and we should have designed the vehicle better. So we do design it to be there. That's why we have the Design for Natural Environments document. I mentioned that on a previous call to Disney, and design it to sit out there, to tolerate rain, to be protected from lightning as much as we can. Thank goodness, as we've seen in some of those other launch attempts. I worry about this rocket if it were bright and sunny all the time, because this is our first one and our flight test that has absolutely critical objectives that are going to be difficult to achieve. And so I'm going to worry about this rocket until we see that capsule safely back in the well deck of the Navy ship.
Thanks. Our next question is from Jeff Faust of Space News.
Good afternoon. Jim, you mentioned the wind limits. You had the 74 knots at the 60-foot level. What were the wind limits at the other levels you were taking measurements at, and how did that compare to the peak gusts you recorded? Thanks.
Yeah, Jeff, so there's some sensitivity to some of the other ones that were related to some ITAR restrictions, but you know, we measure all the way up to the 457-foot level, and that's where you get speeds up over like over 90 knots, over 100 miles an hour. So that's I'll bracket it that way at the 60 and at the 457.
Thank you. Our next question is from Kristen Fisher of CNN.
Thank you, Jim. I guess just following up on your answer to Jeff's question, how exactly how exactly would the wind speeds and the various wind limits at various heights on the rocket constitute a possible ITAR restriction?
Yeah, it's how we do the calculations and on the design of the vehicle, and you can kind of bring some of that together and draw some conclusions that would violate that. Much like, you know, ITAR and export control really get us. It's not necessarily the raw data, it's how you can put it together to infer different things.
Thanks. Our next question is from Kenneth Chang of New York Times.
Hi, thanks. I was wondering what sort of drives the certification limits for wind. Is it that the wind might blow off the insulation, that debris can get blown into it, or is it torque on the underlying structure?
Yeah, it's really both. So it's strength and fatigue. So if you think of the wind gust and you know, kind of pushing on the rocket, and the strength to hold it there, and then there's the fatigue as the wind varies and you drive cycles into the rocket, much like we talk about the fatigue that when you ride out to the pad, because you're cycling the rocket back and forth. So that's the two parameters that we really look at, and the wind gusts here are really driven by the strength side of things. And in this case, we saw absolutely no increase in the risk to the strength of the vehicle.
Thank you. Our next question is from Marcia Smith of spacepolicyonline.com.
Thanks so much. Jim, you talked about the 2.5 to 3 hour meeting that you had discussing whether or not you should stay at the pad or roll back. Could you talk a bit about whatever meeting you had to decide to go ahead with the 16th? And, were there any voices of dissent that really thought you should do some additional tests before you try the next launch? And if you did decide to wait, say, until the 19th, what additional tests would you like to see done?
Yeah, thanks, Marcia. I don't. So the previous meeting, and I'm getting my days mixed up because I was kind of transiting on some travel, but it was either the Thursday or Friday before, and we talked about whether to roll out or not. We spent usually on the front end of those meetings, it's all about the weather. So that one was about the weather. And then we moved into the discussion about pros and cons about rolling out. And and I don't know that there were any dissenting. I think there were some folks that talked about, hey, the best place to be is the VAB, but I'm summarizing here. The storm looks like it's loosely formed, doesn't look like it's coming this way. We have time to get out to the pad, and we have the limits that for Hurricane Ian, that we did a lot of work in revisiting and thinking about wind speed and direction, and so I don't know that there was anyone that dissented, but there were folks really thinking it hard through whether we should roll out or not, and all agreed that in the end, everyone agreed that we should roll out. I think we always try and look for, and I'll start with myself as a leader, try and look for the dissenting opinions. That's what we learned on Challenger and Columbia. That's why we have the model that we have in the agency of technical authority today, and the path for dissenting opinions. There weren't any there. I felt like we had the discussion we needed to have on that Thursday or Friday. Again, I can't remember the dates right now. And then on Sunday, we did have the discussion, and folks had the chance to weigh in. We have a daily board that's chaired by Tom Whitmire, and Tom does a great job at soliciting the opinions and trying to make sure that everyone has the chance to be heard. And I think we lived by that on that Thursday or Friday. We lived by that on Sunday. We had a daily board today where a number of issues came forward, just like they do every day. This is a dynamic process, and I think the right discussion was had.
Thank you. Our next question is from Emery Kelly of Florida Today.
Hey, folks. Thanks for doing this today. With hindsight in mind, and the fact that obviously our knowledge about hurricanes and hurricane season is kind of constantly evolving, and obviously now that everyone tends to breathe a little bit of a sigh of relief when November comes around, but not always. Are you, and I know you mentioned this briefly, but are there any serious discussions about, especially with things like climate change in mind, possibly changing constraints, or in the future, if it's, October or November and you see a 10% chance of a storm developing and it's right before rollout, are there any considerations about maybe changing those rules in the future? Thanks.
I think we've been keeping a list of things that we want to look at as lessons learned for Artemis II that we're going to walk away from Artemis I with. And, there's a great list. We've talked about some of them on here, pad access as an example, or how we're processing the vehicle to do better. I think there's things we've already implemented. Charlie Blackwell-Thompson's work with the team at the pad in shortening our pad flow, or Cliff Lanham's work going back to the VAB and access to the vehicle, or how we involve the prime contractors and things to get stuff moving faster, or how we process paper or process nonconformances. I think there's a whole list of things. I think we certainly learned about the vehicle at the pad, and going through a a major weather event. So I think I would add that to the list of how do we approach things if we see something develop in a storm like this, knowing that it happened. Yeah, I think we add it to the, hey, let's think about this the next time we process a vehicle, which will be Artemis II.
Thank you. Our next question is from Ramin Skiba of Wired Magazine.
Hi, thank you. I was wondering, like, suppose this were, the rocket for the Artemis II mission, the crewed mission. Are there concerns that you would have if there were crew on this flight, like with the Orion capsule or with the integrity of the rocket? Like, are there certain things that you feel less concerned about the possible risks that you would otherwise if there were crew on board?
What I'd say is we're never going to get to Artemis II if Artemis I isn't successful. So obviously we care about any vehicle that has crew, but this vehicle is just as important because we need to fly it and achieve our 3 test objectives in order to get to Artemis II. The vehicle requirements, the vehicle design limits that I talked about for wind and strength and fatigue, are going to be the same as they will be when we fly crew. So from a requirements perspective, from a vehicle importance perspective, I think we look at it the same way, and people care about the quality of their work regardless. We'll always look at things hard when we put humans on there, but from our perspective, from requirements, we were within the requirements limits, and the strength of this vehicle is strength of the design of this vehicle is the same as the strength of design of Artemis II.
Thank you. Our next question is from Chris Gapehart of NASA Spaceflight.
Hi, yes, I want to kind of focus a little bit on getting to the 16th now. So, Jim, I know you mentioned some items that are still open and that the teams are working here. Is there like a major path critical item that you all are tracking right now to the 16th? And then also I want to sort of go back to the hydrogen leaks of the past. Like Charlie had mentioned that there were some indications that rolling out might loosen the torque on the bolts, which led to some of these earlier leaks before the pressure event. And I'm wondering, with rolling out and now a hurricane buffeting those for a few hours, do you have any plans to retorque the bolts on the LH2 side of the tail service mast umbilicals just as a precaution at this point? Thank you.
Yeah, right now we don't have plans to retorque those. The engineering teams, of course, are looking stuff all the time, but that's not in the current timeline. To your first question, what's the major critical path? And we have to get through the vehicle power-ups today. We have to get through those program-specific engineering tests. We have to get that harness replaced. First the examination of the existing, and then if we have to replace it, we'll have to get that replaced. So I think it's kind of the standard set of cadence of things leading up to the countdown that we have to get to, that I would say is our critical path.
Thank you. Our next question is from Stephen Young of Spaceflight Now.
Thanks, Catherine. Jim, could you, just to follow up on Chris's question a little bit, could you talk more about the contingency time you might have in the schedule to meet the launch date of the 16th? You obviously had some disruption because of the storm. What are the normal things that haven't got done at this point that you're trying to get done to start the countdown? And if the 16th isn't an option, how do things look for future options down the line? You had talked about having to perhaps talk to the FAA if you needed more launch attempts.
So I'd say the things we have to get through are what I mentioned. So let me back up. So we made the decision to move off the 14th because it was going to be pretty clear that the storm started moving a little bit slower, so the arrival time, when we were still talking about the 14th, pushed out, which really compressed our work on the backside in our normal flow. Things like the vehicle power-ups that I mentioned and getting to a countdown start time. So that's why we moved off the 14th and moved to the 16th. The work that we have to do, the vehicle power-up and the program-specific engineering tests, are things we're going to do anyway. So I wouldn't say that there's a so I'd say that's the path. Contingency time, I don't want to take a guess at the time right now, what Charlie has in her flow, just because that's hers, and I don't feel right trying to guess at that. As far as future launch dates around the 19th and 25th, we do have both of those as backups right now. With the range, and the FAA gave us the date of the 25th, so we're already cleared with them. If we need to start to think about others, then we'll have to do that. But right now we're focused on the 16th, and if we get stuck on something here that we find during these power-ups or engineering tests, then we'll have to think about the 19th. Right now we have a path to all three of our current launch attempt dates.
Thanks. Our next question is from Mike Wall of Space.com.
Thank you for doing this. Just a quick question about the team. They just made it through a hurricane, and I'm sure everybody's a little stressed out, and this has been a very long process, trying to gear up for this launch. I mean, how are they doing? And is there a point coming up where you might meet up against a fatigue issue where you'd have to stand down for a day or two to give folks some time to rest or to recharge?
Yeah, I appreciate the question. We spend a lot of time talking about hardware and launch dates and technical issues, and ultimately the most important thing that we have, the greatest asset that we have, are the folks that show up to work every day. And I will tell you, I really hope we can somehow find a way to show you that picture of the high crew today doing that repair, because it reinforced for me the lengths to which people go to support this program. And it's people 300 feet off the ground trying to move an umbilical back, to trying to figure out a software problem in the control center, to keeping a portable purge unit running to keep a purge on Orion at all costs. And I know that Charlie keeps really good track of her team, how they're doing. Our mission management team, led by Mike Serafin, I know Mike gets sleep schedules to his folks to make sure they're ready to go, checks in with them. John Honeycutt on SLS, I know cares about his folks and checks in. Howard, who on Orion, does that, and as does Mike Bolger in Exploration Ground Systems. So I think people are a priority everywhere. So my assumption is, and the folks I talk to and check in with, certainly not to the same extent, but those individuals keep track of their folks, and I would expect if there's an issue, they would bring it forward. I know they highlight it in their staff meetings. So right now, I think the team's ready to go and committed. It goes back to my earlier point of there's nobody cavalier about what we're trying to do, and I've tried to reinforce, going back since not long after I started the agency, putting something out to the entire Artemis I team that said, if you see something that isn't right, you should raise it, and I count on folks to do that.
Thank you. Our next question is from Doris Arisha from Inverse.
Hi, thank you so much for doing this. My question is about the tail service mast umbilical. You mentioned it came off its tray. I'm hoping you can explain what happened a bit more and what's been done to fix that. Also, was this the same feature that received repairs following leaked propellant in the wet dress rehearsals? And if I remember correctly, also on at least one of the launch attempts? Thanks.
Mm-hmm. Yeah, what came off the tray was actually at the Orion level. So it was one of the Orion umbilicals. So it's not at the bottom of the vehicle. At the bottom of the vehicle is where we had the hydrogen issue. The connector, the electrical connector that we're having the problem with is at the tail service mast umbilical end. What came off the tray was up at the Orion side. That's been fixed, and we're looking at the electrical connector at the bottom of the vehicle.
Thank you. Our next question is from Michael Greshko of National Geographic.
Hi, thanks for doing this. I just wanted to double back to the ITAR considerations for peak wind speeds above heights of 60 feet. Could you explain how the ITAR restrictions jibe with the fact that natural environments design spec document you mentioned is public and includes peak wind speeds up to, I think, 490 some odd feet, 492 feet? Thanks.
Yeah, like I said, it's when you put a bunch of information together that it becomes the restrictive side of stuff. So I sense the interest there. So what I'd like to do is circle back with John Honeycutt and John Blevins and get you the detailed answer there. I don't want to put my conjecture out there any more. I believe I have said what I can say, but let me back up and check with the experts again.
Thanks. We've got time for a couple more. We'll go to Lisa Grossman of Science News next.
Hi, thanks for doing this. Thanks for taking my question. I was wondering how many rollbacks do you have left if you do ever, after inspecting it more, if it turns out you do want to roll the vehicle back into the VAB, how many more times can you go back in and out?
Yeah, the vehicle's designed, I'll say the current analysis supports 11, right? So we have, 6 left, 6 rolls left, and we'll not roll and there and back. One way is what is one time is 1 out of the 11.
Thanks. We'll take a question from Christopher Mick of the Hudson Star Observer next. Christopher, your line is open.
Thank you for taking my question. I wanted to circle back on the timeline between now and launch day, when the decisions would happen for, you mentioned that kind of loose ATV material about snipping that off, when that would be made, when testing on the umbilical might make a decision for replacing that, or if a repair will be enough, just what that timeline between now and launch day might be for those items.
Yeah, I think those decisions are probably quickly upon us here. I think the RTV one will be very near term. I think the engineering teams were meeting about that as we were on our as I was able to participate in the daily board call a little bit ago. On the electrical connector, as I mentioned, they were out there looking at it. They had gone and located the backup harness, so those decisions would probably have to be made here this evening, because for the umbilical, we're going to have that in place when we would do the program-specific engineering tests on Sunday. So within the short term, meaning tonight or tomorrow morning, have to make those decisions.
Thanks. Next, we'll go to David Denault from About Space Today.
Good afternoon, Jim. I have a question to go back with the issues that we've had in 3 launch attempts, and I kind of wonder why couldn't we have waited a little bit and go with a daylight launch? And I've heard that time and again. Oh, we'd prefer a daylight launch, or we would prefer a daylight launch. What happened?
Yeah. So first of all, we've had 2 launch attempts, just to set it straight, and a tanking test. As I mentioned, I forget when we had the last call. We have said we would prefer a daylight launch, but we've also said that we were okay with a nighttime launch. The daytime launch gives us more imagery, but the imagery we have on a nighttime launch is sufficient for us to do the engineering assessments that we'll have to do for the vehicle for future missions. So, and as I mentioned on I think the last time I was on with you all, we did, I shouldn't say we, our leadership under Tom Whitmire reconvened the control board and made sure that everybody was comfortable with the daytime launch. That includes all of our technical authorities. So we did validate that again, and everybody's comfortable with a nighttime launch. So hopefully that distinction helps. We get more imagery with a daytime launch, but we have enough imagery to do our engineering assessments if we were to do a nighttime launch.
Thank you. Our next question is from Ken Kramer of Space Up Close.
Hi, Jim. Thank you for doing this. My question is, I want to go back to the storm and the rollback. So Sunday evening, you said you didn't have enough time to roll it back Sunday evening. I'm wondering how much time would you have needed from Sunday evening to do the work? When could you have rolled it back, if the time had been available for the storm? Thanks.
Yeah, I think I don't have those charts right in front of me, Ken, but you know, we had to we had to do a number of disconnects and reconfigures to be ready to do that. And if I remember right, it was going to be like late Tuesday, Wednesday time frame, and maybe it was midday Tuesday. And then the wind speeds then were predicted to be like I think 35 knots sustained and gusting up to 40. And at that point, you know, it was gonna that's where that trade came in that I talked about staying or rolling. So it wasn't like we could just we had the opportunity to just you know, kind of go back right away. We may have taken it, but that's really what the trade came down to, was the winds. By the time we were going to be ready on Tuesday, we weren't going to have the favorable winds that we want when we roll.
Thank you. Our next question is from Manuel Manzanti of Debate.
Thank you, Jim. It's okay. You just answered my question a few minutes ago about the limit of rollouts and rollbacks, so I'm okay. Thanks.
Thank you. All right. Our last question will be from Emmy Victor of AccuWeather Channel.
Jim, thank you so much for taking the time to answer all these questions. I guess just to kind of wrap up here, I was wondering what comment or analysis we could expect on this in the future. Is NASA in position to release a report showing all the wind sensors at Kennedy Space Center, the peak sustained winds, the peak wind gusts, the location of the wind sensors, the height of the sensor, all the things we discussed and more on the call? Is there going to be a public report indicating some of these as well?
Yeah, thanks for the question. I mean, I don't know that we'd ever, you know, just exhaustive like that. Maybe let me take the action to see if there's kind of a one-page summary we can put out of everything I said at the beginning, of everything that factored in into this, at least just to be as transparent as possible of some of the data that we put together. I think that's a fair ask. But let me see what we can do. Even if we put, I know Catherine, we've been trying to continue to do a blog, and Catherine and Rachel Kraft, I appreciate all of their work to stay on top of this for us and share as much information. Maybe we can at least put a little bit of the data in one of the blogs. So I'll work with Catherine to do that. And Catherine, I know you want to wrap it up. Let me just say one thing here at the end. But when we make these choices, the thought and analysis that goes behind it from our technical teams and talking about risk is exhaustive. And what we do we're always talking about the risk of flight. What we do in just processing this vehicle and trying to manage risk and accept risk is a structured process, and we do the absolute best that we can. And I don't want to say we, because it's the technical teams that work this and the management of those technical teams that work really hard to make that happen. So I want to thank them for all of their hard work and keeping us on track, taking care of the vehicle as best they can. In this storm, designing it for this kind of environment is difficult and challenging, and in this case, the design, I think, stood up to the test of this storm. We'll look at every condition we put this vehicle through very carefully in processing it and in flight, and I'm looking forward to this mission and the objectives we're going to get through. There will be challenges along the way. We'll share those challenges with you. Many of you, when you start your questions, say, thanks for doing this. This is important for us to do. I know many of you would love daily where are we at, but that's just not possible. But I will do everything I can to share the information with you as fast as I can and get the right amount of data to you that we can share. So thank you for your time and interest, and we'll keep talking about getting to the 16th.
Thank you, Jim, and thank all of you for joining us today, and thank you, Jim, for taking the time to talk to reporters this afternoon. You can listen to a replay of this teleconference online by visiting the Media Resources tab at nasa.gov/Artemis-1 later this afternoon, and follow along at our blog for updates about the mission at blogs.nasa.gov/Artemis. And with that, thank you again for joining us.
Thank you. This concludes today's conference call. You may go ahead and disconnect at this time.